from AD Academy. In my previous video in this playlist I have talked about activation function, and in the second part of that I have talked about different types of activation function. In this video I will talk about different types of activation function in details, their mathematical formula, how we derive those things, and the application with advantage and disadvantage. My name is Dr. Ayan Debnath. I have secured Ph.D. degree from IIT Delhi in data science. As a visiting research scholar, I also have research experience in Harvard University and University of Pennsylvania. Total 8+ years of experience I have in this field of data science. So let's watch this video till the end to know about different types of activation function with mathematics in depth. Next one is Swiss ReLU. Swiss ReLU is another variety of this ILU, or maybe you can say leaky ReLU. This is more kind of smooth. So this is a kind of a self-gated function, and since it is smooth in both the side, like kind of leaky ReLU or ReLU, it doesn't abruptly end in zero. It is more smooth in this region. Mathematical function of this is x multiplied by sigmoid of x. Swiss ReLU is generally used in case of LSTM, where number of hidden layers is more than 40. If it is less than that, then we don't use Swiss ReLU. If it is like more number of hidden layers are there, then we use Swiss ReLU. 10th one is soft plus. The function looks like this. It is very soft. So like it means that in other case, like we know, like these things, it is like this, right? It is very soft. The function is f of x is equals to ln of, ln is like the log of exponential of x plus 1. This is a mathematical function. Since this is very softer, we can use it in like different kind of places, but the thing is that since there is an exponential term, so obviously the time or the computation time will be very high. Next one is softmax. This is where we use this kind of activation function in case of some probabilities. We are calculating the probabilities in the neural network, and say for some class of like multi-class classification. Say we are doing a classification of dog versus cat versus lion versus say monkey. So we are doing kind of 4-class classification, where we will be getting 4 different values of the probability. And how we are getting these values of the probability? So there is one function e to the power z by summation of e to the power z of I, where I runs from 1 to k. This will give you the probability value. So for each of the output, say these are output, here we are having the hidden layer, and here we are giving different kind of input. This is the hidden layer, and this is the last layer, that is the output. So it is giving different kind of probabilities. So this calculation we are doing in this region, and after calculating it we are finding the probability. Say for example, if the probability of say dog is 60%, so it is like this. Probability of cat is say 20%, probability of lion is say 0.1%, then monkey will be also 0.1%, because ultimately since it is a probability, so summation of all this number will always add up to 1. And while taking these things, we have to calculate this probability, so it means that e to the power 0.6 divided by e to the power 0.6 plus e to the power 0.2 plus e to the power 0.1 plus e to the power 0.1. This is the probability for the first case. Now probability for the second case, it will be e to the power 0.2 divided by summation of all the numbers, like this thing, same denominator, then e to the power 0.1 divided by the same denominator, e to the power 0.1 divided by same denominator. In this way we are calculating the probability, and whose probability will be higher. See, if this dog's probability is higher, then the output will be a dog, and if the probability of say this one like lion is higher, then the output will be, it will predict that yes, it is a lion.